Welcome to our video about determining limits graphically. That's a tongue twister. Alright, so what's going on, and I'll just give you a quick preview of this video. We're going to look at stuff like this, where we have a graph and there's like a point missing, then we have another point colored in instead, that kind of stuff. Just really funky graphs. And there's going to be some technical details and some little exceptions and stuff and some rules you have to use figuring out what the limits are on these puppies. But ultimately, and we'll even do one where things shoot off to infinity. But the moral of the story is that these are kind of, at their base, they're just like the easiest problems where you plug in a point. So if you take a look at this one, just a line, equation of a line. Now, because by the time you get in calculus, you're pretty good at the equations of lines, so you'd probably be able to figure out what function this is. It'd be like x plus 2 or something. But for the purpose of this type of problem, we're not going to figure out the equation. Because if we had the equation, we want to take the limit as x approaches 2 of a function. If we had the equation, we just plug 2 into it, right? That's the thing I said you should also always do first on limits problems, just try plugging in the number. Well, we can't do that because there's nothing to plug it into. So what we're going to do is sort of like the graphical version of just plugging in. And that's just finding the point. Because whatever the y-coordinate is, if I wanted to plug in 2 to a function, wouldn't that just be f of 2? That's all I'd be finding. F of 2 also happens to be right here. It's the y-coordinate. If you plug in 2 for x, f of 2 is just whatever your y-coordinate is at that point, at x equals 2. So since the point 2, 3 is on this graph, f of 2 equals 3, and that's what you would have found if you just plugged in 2. So to find the limit as x approaches a number off of a graph, all you're going to do is go to that x-coordinate and just see where the graph is, like right there. And your answer is the y-coordinate. So same thing in this thing. We basically want to plug in -3, so we're just going to go to x equals -3, and that's right here. See what the y-coordinate is. Looks like it's -2, and that's our limit. The y-coordinate at -3 is -2. And last one, the y-coordinate at 0 is +1. And bingo, we're done. Not too bad, right? So that's kind of just like plugging in. Now in this one, very similar story. We're just going to go to x equals 2, see what the y-coordinate is, 1, and that'd be 1 right there, and that's our answer. Go to -3, y-coordinate is 0, so that's our answer. And finally go to the x-coordinate 0, looks like our y-coordinate is -2, so that is our answer. So basically it's just like plugging in points, and I want you to think of it as being that easy. They're really just saying, hey, what's f of 2? What's f of -3? What's f of 0? Where these things get a little bit trickier is in situations where you can't actually plug in. So if you recall from pre-calculus, and this probably came up in algebra a little bit every once in a while, that whole open dot phenomenon. So what this is saying is, the reason this empty circle's right there is saying, yeah, this is the line. A line is just a set of infinity points, right? Just a million jillion dots so close together that when you look at them, it looks like a solid line, but really it's just like infinity little dots all next to each other, infinity points, except for this one. This one point that would have been right there at x equals 2, but it's missing. Why is it missing? I don't know. If you're really quick with the functions, you might be able to cook up a function that would give you this line, except be missing that one point because it's not in the domain. But the point is that this function does not exist at x equals 2. However, we can still find the limit as x approaches 2. So the point is that because it doesn't exist at 2, if somebody said, hey, what's f of 2? You'd be like, does not exist. Oops. DNE, does not exist. The limit doesn't exist. Or the f of 2 doesn't exist. It's empty set. It's not in the domain. Just, the domain of this function is everything except 2, so you can't find f of 2 because it's not there. However, you could take the limit as x approaches 2. So what that means is, hey, if we were driving along this street, headed towards that point at x equals 2, when we were getting right up before we got there, wouldn't we think we were going to land on the point 2, 3? And therefore the limit would be 3, because that's the y-coordinate right there. Same thing if we had been driving from the south, sort of, up, going towards the point that direction. Once again, it looks like, if we're driving in a fog, we're looking at our GPS, and it sure looks like we're about to end up 2, 3. And therefore, that's why I think that 3 is the limit. Whether you're coming from the left or the right, it looks like where we're going to land is 2, 3, so that's what I'm going to put down as my limit. Turns out that point doesn't actually exist, right? But for this limit problems, that doesn't matter. All that matters is where you think they should go, where those two lines look like they're going to meet up, is all that matters. It doesn't matter whether they actually end up being defined there or not. But that empty dot only affected that one little spot. What about when we want to plug in -3? Well, now we're just back to normal, because over at -3, there's just a normal line. There's nothing funky going on. So to plug in -3, just go to -3. Looks like our y coordinate is -2, and that's our limit. Oops, -2. Want to plug in 0? Looks like our y coordinate is 1, and therefore our limit is 1 as x approaches 0. Pretty sweet, right? Now, what's the wrinkle here? Well, once again, we have a line with a missing dot, but then we went ahead and put the dot in up there. So if you remember pre-calculus piecewise functions, maybe this would have been like, you know, for like -infinity to infinity, f of x equals 3, except when x equals 2, f of x equals 5 or something. Point is, we got a point up here and a missing point right there. Still a function because it passes the vertical line test. We have an extra dot up here, but then there's nothing underneath it because there's an empty dot right there, which is technically nothing. Anyway, we can still go ahead and plug in on the limits, and you'll see that something kind of interesting happens at 2, where this empty dot situation is. If you want to plug in 0, same old story as usual. It's just you go x equals 0, go up, see the y coordinate is 3, so that's going to give you a 3. X equals -5, somewhere over here. Once again, y coordinate over here is going to be 3, so the limit as x approaches -5 is also 3, because if you're driving along this line, it looks like when you get to x equals -5, you'll be at 3. And this is a horizontal line, so it really doesn't matter what you plug in for x, you're always going to get 3, except for one spot, right? And that one spot is at 2. So, what happens when you plug in 2? What's f of 2? Well, gosh, f of 2, that's this point up here, isn't it? That's the one time on this graph that y does not equal 3. We got this point up here, 2, 5, which means that f of 2 is 5. Pretty crazy, right? So you'd think that the limit as x approaches 2 would also be 5. But it's not. Because if you were driving along this road approaching 2 from either direction, coming in like this, doesn't it look like these two lines are going to meet at 2, 3? It does, right? They're just going to keep, and they'll collide right at 2, 3. But then what happens is, like Wile E. Coyote, all of a sudden he pulls the rug out from under you, and actually, no, it's up here. But the thing is that until you get to here and find out there's an empty dot, as they're approaching, it sure looks like they're still going to be at y equals 3. And therefore, the limit is 3, even though it turns out the actual value, if you ever got to 2, was way up here at 5. So that's a really great example of where our limit and what we would get if we actually plugged in are two different things. But what you'll notice is whenever you get one of these graphical problems, the only way to make that happen is with a crazy graph like this. There's no real way to come up with a function that does that funky stuff. So basically you just want to get in the habit. You'll see this again and again. If someone asks you what's the limit approaching -1, you just be like, oh, well, even though there's an open dot, coming from either direction, it looks like we're headed for that point at the tip of the v, which is at y equals -2. And yet I know that if I plug in -1, that's this point. So that's going to be a y value of 2. So the limit is where do we think we're going to end up as we drive closer along the curve, and then f of whatever, the actual value, is wherever that dot really is, if it doesn't agree. All right, last one I want to show the graphical version of. Now, by the way, I'm going to get some even harder graphical problems are going to be in a video about piecewise functions and stuff, where it's going to get gnarlier, and one-sided functions, also like tons more of this graphical stuff. All right, so asymptotes. This is kind of a special case. Limit as x approaches -1. As you can see, at -1, this thing is not defined. We've got a vertical asymptote. So that probably means that if you had the function, it's probably a fraction that's got like an x plus 1 downstairs, because that way when you plug in -1, you get 0 downstairs, which kind of gives you infinity, right? But technically it doesn't exist. So even though you might be tempted to write down infinity as the limit, because as we're approaching -1 from either side, it looks like we're going to hit at infinity. Like as my fingers come closer together and we swoop up to, it looks like we're going to hit somewhere up at infinity land, so you might just be tempted to put down infinity. But technically, these lines are never going to meet, and it's increasing without bound, which is limit does not exist. So D and E, or whatever your particular teacher likes to write. Usually they say limit does not exist or D and E. F of negative 1 is just does not exist also. It's not infinity, it's just undefined. So if you have a teacher who's kind of a stickler for the stuff and which word to use in the vocabulary and exactly how to write everything, definitely find out. If you can't figure it out from your notes, ask your teacher just point blank the day before the test or quiz or whatever, hey, if we get no limit, how are we supposed to write that down? Because it's always a bummer to get some points taken off for not writing down everything the way your teacher prefers it. So just go ahead, figure that out, ask your teacher early, and then don't lose any points later. All right, so everything we just looked at involved the two lines coming together like that, right? They were either meeting up here, or they're going to come together in a V, or there's a dot missing an angled line, but it looks like that's where they'd meet, right? In the next video, we're going to talk about one-sided limits, which is where things are coming in, but they're not actually going to hit. And it turns out you'll take the limits separately, like from the left is different than from the right and stuff. So stick around for that. Some fun notation with that as well.